So we have y equals L y naught times 1 over, etc. And we rewrite that slightly. I'm going to put the y naught back into the numerator here and write it in this form. And the reason for that is we've seen what happens as t approaches infinity. We want to try to make it clear what happens as when t is close to 0. Now, obviously, still when t is large, e to the negative klt is close to 0, making this term close to 0, making this quantity close to y naught divided by y naught, which is 1, so that y is approaching L. For small t, we're going to make use of the fact that the e to the klt, if t is small enough, is approximately equal to 1 plus klt. Now I said if t is small enough. I mean if t is small enough that klt itself is a small number. Why does that approximation work? Well, that's just a result of the Taylor expansion. The Taylor approximation to e to the x is e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. Now, if x is a small number, much less than 1, then x squared is going to be much less than 1, and x cubed is going to be much less than that. So that e to the x is going to be very close to just 1 plus x. All these higher order terms are easily shown to go away, to become insignificant when x is small enough. Now, if we replace x by klt, then we get e to the klt is 1 plus klt plus quantity klt squared over 2 factorial, etc. If t is small enough, klt is small enough that we can ignore the higher powers. So, by small enough, we mean that t is small enough that this approximation is valid. Now, in order to apply this, we simply substitute 1 plus klt. Well, actually, first we multiply both sides, numerator and denominator of this equation by e to the klt. E to the klt times y naught is going to give us y naught e to the klt. E to the klt times this term is going to multiply the e to the negative klt, which is going to give us e to the 0 or 1. And that's just going to end up giving us an L minus y naught. And in the numerator, y naught multiplied by e to the klt is, of course, going to give us y naught e to the klt, but we're going to write the e to the klt out here, anticipating what's going to come. One more simplification down here, or modification of the form. Don't know if it's really a simplification. If we distribute the plus through here, we get this plus L minus y naught, and the minus y naught will combine with the y naught e to the klt. Factoring out the y naught gives us y naught e to the klt minus 1, leaving us the L over here. Now we'll see in a minute how this expression can be used to investigate what happens when klt is small. That is, when t is small enough that klt is much less than 0.